Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the continuation of area bounded by a curve, and today specifically, a curve bounded by another curve or line. So this is part 7, and I encourage you to subscribe in order not to miss out on our future uploads. I also encourage you to check out our previous videos, that is part 1 to part 6, for there is a lot that you can benefit from those videos. Now, diving into today's business. If we have two functions, f1 of x and f2 of x, that intersect at points a and b on the x-axis, like the one presented in the graph here, we see that the first graph in blue, f1, is higher than the red graph f2. That is in terms of the y-axis, but we are starting from the x-axis. So it means that the graph f1 of x would have a higher value compared to the f2 of x. So that is something that we have to bear in mind. So if f1 of x is higher than f2 of x, that is on AB from the x-axis, then the area of the shaded region is given by the integral from a to b of f1 of x minus f2 of x dx. Otherwise, we would have the area being given by the integral from a to b of f2 of x minus f1 of x. Why? Because the graph of f2 of x will be higher than the graph of f1 of x. Great. Let's take a look at an example. The diagram shows part of the curve with equation y is equal to minus 2x squared plus 8x plus 11, and the line with equation y is equal to 8x plus 9. So in this case, we have that, and the graph of the quadratic is one that is above the line. So it implies that that graph would have higher values or higher area compared to the one that will be generated by the line. So in that case, we would need to subtract. But before we do that, let's find the coordinates. So we need the coordinates of point A and the coordinates of point B. Those ones are crucial because as we integrate, we would get the lower and the upper limit from the two. So to do so, we equate the two equations, the quadratic and the linear. So from there, we move on to group the like terms. As we do so, we are going to have minus 2x squared plus 11 minus 9 is equals to 0. So simplifying that, we have minus 2x squared is equal to minus 2, implying that x squared is equals to 1. Now solving for x, we get two values, plus or minus 1. So meaning that the x coordinates of A is minus 1 and the x coordinates of B is a positive 1. Right, we move on with that. The next thing is to find the difference between the two graphs. And recall, the quadratic is higher than that of the linear graph. So we subtract, and in subtracting, we get minus 2x squared plus 2. That is our function that we are going to use to find the area shaded. And we are doing so from minus 1 to positive 1. So the integral from minus 1 to 1 of minus 2x squared plus 2 dx, when integrated, would give us a minus 2 over 3x cubed plus 2x from minus 1 to 1. Then substituting the limits, we are going to get 2 and 2/3 square units as our final answer. Now, let's look at example 2. With example 2, we've got two curves. So both of them are curves. We don't have any line, but the procedure is the same. So according to the question, we need to find the x-coordinates of the points of intersection of the curves. So we can see that there are 3 points of intersection. One automatically is 0 in the x-coordinate. Then we have the other 2 values that are positive. And those are the 2 values that are of interest to us in answering question 2, but part A. So for the solution, in order to get the points of intersection, we would need to equate the 2 equations. So as we equate the 2 equations, we get a minus x cubed plus 4x squared minus 3x is equals to 0. Let's label that equation 1 because we are going to refer to that equation later on. Great. So let's move on solving for x for this equation. Right, as we see, we have x's throughout all the left-hand terms. So we can factor out x because that is the common factor in this case. Then we have x squared minus 4x plus 3 is equals to 0. So we have that. And recall, from the quadratic factorization video, we see that we get x times x minus 1 times x minus 3 is equals to 0. And setting all these 3 terms or parts to 0, we are going to get 3 x coordinates. And x is 0, which we had already, x is 1, and x is equal to 3. So we have our 2 limits. X is equal to 1 being the lower limit, and x is equal to 3 being the upper limit. Then, to find the area, we subtract y1 from y2 as it is higher on the x-axis, or we use equation 1. So it's better to just use equation 1. That is the reason we highlighted it and labeled it as 1. So in this case, we have minus x cubed plus 4x squared minus 3x. That was our equation 1. So we're going to take the integral from 1 to 3 of minus x cubed plus 4x squared minus 3x dx. Now, if we integrate these terms individually, we're going to have a minus 1 over 4x to the power 4 plus 4 over 3x cubed minus 3 over 2x squared. From 1 to 3, we substitute the lower limit and the upper limit. Recall, we start with the upper limit. So when we evaluate, at the end of the day, we are going to get 2 2/3 square units as our final answer. Now, if you have made it thus far, I say to you, congratulations. Thank you so much for watching Numbers Simplified. I leave you with the following task. Remember to like, share, and subscribe. God loves you.